the progressive wave equation. Now we're given this equation and we are asked to find what? We are asked to find the velocity of the wave. We are asked to find the velocity of the wave. To find the velocity of a wave, we need to get the parameters we need before we can be able to find the velocity of wave. Okay, so first thing is to rewrite this equation. That is, this equation given to us, this equation, we need to rewrite it back. And yes, rewriting the equations, this is the equation. Okay, this is the equation we're given. And we want to calculate the velocity of this wave. So first thing I need to do is to use this pi. This pi that is here, to multiply it, to open this bracket that is inside. I will use this pi to open this bracket that is inside. So if I use this pi to multiply this, so this is what I will have. You can see it now. Okay, so that is for that. So what is the formula we need to calculate the velocity of this wave? So the formula is velocity equals to frequency times what? Times lambda. That is frequency times wavelength. Frequency times what? Times wavelength. And so we need to get our frequency and we need to get our wavelength from this what? From this equation. We need to get our frequency and our wavelength, because this F stands for frequency and this lambda stands for wavelength. So to do that, bring back the equation. Of course, you know that this is the original equation that was given to us. And this equation that is here is the equation, is the progressive wave equation. Is the what? Progressive wave equation. So what I will do in this video is to do what? I will compare this equation here with the equation given to us for us to be able to get the parameters we need. And what are those parameters? Is just frequency and wavelength. So those are the parameters we need for us to be able to calculate the velocity of this wave. Okay, now how am I going to go? I will go about this by saying, okay, now you can see that here is sine theta, that is, here is sine, right? Here is sine, and then A here stands for what? What is here? Because this sign that is here is this. So our A there stands for amplitude. So this is our A. But we don't need A in this question. We don't need the value of A. I don't need to touch that. Now, the one we need is one. If you look at this equation given to us, if you are to compare this with this equation here, now I've compared A sine with this. Now you can see that I've compared it with this. So that is not where we are going to. This is our major concern from here to here, and also from here to here. Now let's compare. Now I will compare this one that has this one here with this one here. I will compare it with this. Why? Because if you not, you will see that the x that is here is also here, right? Compare this. I will compare this with this. Are we following? I will compare this and this together, and then I will compare this and this together. Okay, so to do that, we have this. You know, here now I've already compared this and this together. That is, what is here is equals to what is here. So you can see it here now. Okay, and next thing to do is to do what? Is to cross multiply. Is to cross multiply. And if I cross multiply, this is what I will have. You know, this lambda, we multiply it here, right? That is the wavelength, it will multiply it here. So this is what I will have. Now, having this equation, I can say pi here, we cancel what? This pi. And then x here, we cancel what? This x. So I'll be left with what? 2 equals to 0.5 lambda, just as you can see it here. So if I'm to make lambda, that is the wavelength, subject of the formula, I will divide both sides by what? 0.5. And if I divide by 0.5, Therefore, lambda will give me what? 4. Because if I divide 2 divided by 0.5, that will be 4. And the unit of lambda is what? Meter. So you can see the meter. So that is 4 meter. Now, can we substitute it directly into the equation? No. We have only gotten the value for lambda, that is the wavelength. So we need to get the value for frequency before we can substitute it into this equation. And to get that, we also compare this and this. As I've said, that you will compare this. You also compare this and this together. You will compare them. Now let me ask you a question. Let me ask you a question. This minus that is here, which one do you think that have this minus? This minus that is here too. Which one do you think that have it? It is this that has the minus. The minus belong to this. Why this one too? The minus belong to this. So that is why you can see that the minus appear in both of them. Okay, so that one is not an issue. The minus here, we cancel the minus here. Okay, now I'll be left with this. Now here again, pi here, we cancel the what? Pi here. Then t here, we cancel t here. I'll be left with what? I'll be left with 2f equals to 200. And if I make f subject to the formula, I will divide both sides by 2. So if I divide both sides by 2, f will be equals to what? 100. And you have to put the unit of frequency at the back. Okay, now I've gotten the value of frequency to be this, and I've gotten the value of our wavelength to be this. I think the next thing is to substitute them into the formula. Right? Next thing is to substitute them into this formula. So when we substitute them, we have this. That is frequency, which is 100, times the wavelength, which is 4. So if you multiply them, we have 400 meter per second. And which option best describe that? Option B is the correct answer. Please like this video, subscribe to this channel, comment and share with your friends. See you in my next video. Thank you.